for the reaction of hydrocarbons, the first is substituting hydrogen with chlorine. So we are replacing hydrogen with another chlorine or halogen. For this one, you react with chlorine in the presence of iron chloride and form chlorobenzene. Now here some of the functional group that we have to learn. Now here you can see alcohols, normal we use day-to-day lives, alcohols. So ethanol is the alcohol commonly we use. And then ethers, in alcohol you have a OH group. So when you have OH group, that means you have alcohol. When you have ether group, you have a carbon and carbon in the both side, but you have only O. So this R means a carbonyl alkyl group. That means you have carbon and hydrogens. Okay. So if you have both sides R group, that means carbons, and you have middle only oxygen, that's the ether group. And here you can see aldehyde group means it's a carbonyl group. That means CO. You have C double O, C and oxygen double bond group. So here you can see R CHO. So is in a carbon, in a aldehyde you have a CO and a hydrogen, we call aldehyde. And the example is ethanol, or we call that acetaldehyde. And the ketone, you have a carbon at both sides and you have a C double O group you have. And the C double O group is only there is no hydrogen. So it differs from the aldehyde to ketone is there is no hydrogen, there is another alkyl group or CH group. So we call that a ketone. Like the example is acetone. And the next one is carboxylic group from acetic acid, citric acid, like that. They have CO and a OH group. We call that carboxylic group. So COOH, if you find, that is a carboxylic group. And the other one is the esters. That means you have a R alkyl group and CO and OR, another alkyl group. So in this example, you can see a CH3 CO double bond and a O and OH3 CH3. We call as a ester. The amine group, you have an N group, that is called amine. You can have only N or with the H, NH. So there are several types of amine as well. Okay, now when you talk about the alcohol, it is given as ROH. You have an carbon compound and an OH group, and the most common one is ethanol. It is CH3CH2OH. Grain alcohol, fermentation of sugars and alcoholic beverages. And the other alcohol we use commonly is isopropanyl alcohol, and it's also called 2-propanol, and rubbing alcohol, and it's poisonous. And you have methanol, it's water alcohol, and it's used in paint solvent, and it's also poisonous. So when you're naming alcohol, you have to name here is like you have to given the main chain, the OH, because if you have double or triple bond, the OH is the most important. That is more reactive. So you have to give, you have to select the main chain including the OH, and you have to give the accordingly. Okay. And then you had, when your number, you have to make sure that you are giving the lowest number to the OH, because that is the prominent functional group, and you have to end as a all. And then if the alcohol is not a prominent group, there is somebody else higher than, like a carbonyl or acetic acid, then you have to, as a substitute group, then you have to add alcohol as a hydroxide. Now for example, here you can see here you have 6 carbons there. So we are numbering this carbon chain from left in order to give the OH position to the lowest number. Then you can see the number 5 is going to be my alkenes, the double bond is, and you have 3 substitute groups. So first we'll name the longest chain. You have 6 groups, so it's going to be hex, and then it's going to be hexene, but it's an alcohol we call all. So hexene all, but we have to say, okay, where is my ene? So we are going to put, okay, hex 5 ene all. But where is my all? Where is my OH? 3. So we have to put 3 hex 5 ene all. And then I'm going to say, okay, my substitution at like 4-methyl, 4-ethyl. So who should come first? Ethyl, right? Not methyl. So 4-ethyl, 4-methyl, 3-hex, 5-enol. In reactions of alcohol, the first is the nucleophilic substitution. Here the alcohol is reacted with the HCl, and a Cl minus will react with the CH3 group and form CH3Cl, and the water is eliminated here, and it's called the nucleophilic substitution. The second one is called the acid catalyzed elimination or dehydration. Here acid is needed in order to process this reaction. Here the OH is removed with the adjacent hydrogen, and as a result the water is eliminated. A double bond is formed here. And next is the oxidation. The alcohol is oxidized by removing 2 hydrogen into a carbonyl group or aldehyde group. Then this aldehyde gains oxygen and forms carboxylic acid. So when you talk about aldehyde and ketones, they have a CO group. So carbonyl groups, we call that CO groups. So in aldehyde and ketone, they have CO groups. In aldehyde, you have a hydrogen in one side, so we call aldehyde. In the ketone, you don't have a hydrogen. Both sides you have carbon groups, so we call that R groups. So many aldehydes and ketones have pleasant taste and aromas. Some are pheromones. I know what is pheromones means, like some kind of hormones that attract things. Those are called pheromones. So the formaldehyde is a pungent gas, and formalin a preservative, and also it used as wood smoke, and it is carcinogen. And also acetone is a ketone that is used as a nail polish remover. So when you talk about aldehyde reactions, what happens here is they react. How we form aldehyde is from the alcohol. So alcohol, when the OH and H will combine and form the double O. So from ethanol, it will form ethanal. And also you can form ketone from also alcohol where you have 2 CH3 in the both sides, and then the OH and H combine and form CO and form a ketone. And also how we can reduce the aldehyde, the ketones, and form alcohol backwards. So whatever we did before, we can reverse the reaction as well by reduction. Okay, now we also can add hydrogen cyanide to the aldehydes or ketones. So when you put HCN, what happened? The H plus will go and combine with the O, and the cyanide will combine with the C, and you can add cyanide groups to the aldehyde or ketones. Now we talk about the carboxylic group. In carboxylic group, you will see COOH, CO carbonyl, and a OH group, and it is acidic because it has a hydrogen which can donate H plus. It's sour tasting. Those are all weak acid carboxylic groups. So the most common is citric acid, found in citrus fruit, and the other thing is ethanoic acid, which is called acetic acid, is called in vinegar, and the other one is methanoic, or we call that formic acid. Insect bites and stings, we can find that. So carboxylic acid made by oxidation of aldehydes and alcohol. So you can see the benzaldehyde is aldehyde, and when you oxidize, you can form benzoic acid. And we have ethanol. You can oxidize and form ethanoic acid. It has the highest precedence. So if you have the carboxylic acid given the number 1, there is no way you are given any other number 1 for naming that. So there is no numbers for the carboxylic acid. We just take carboxylic acid, right? So ending with naming, we call that oic acid, and ethanoic acid, acetic acid, something like that. Benzoic acid, okay. So here you can see if you have 2, 1 like ethanoic acid, acetic acid. You have 2 carbons and this is a carboxylic acid, we call ethanoic acid. And if you have 1, 2, 3, 4 carbon and see you have a COOH, we call butanic acid. And here you have 3 carbons and we call a propanic acid. And here you have 5 carbons and we call it pentonic acid. Okay, now we'll talk about esters. Esters are given the formula as COO. If you see a COO, then that means it's an ester. It gives very good smell. You can make from reacting with the carboxylic acid and alcohol. So if you have a carboxylic acid and an OH alcohol, what happened? The OH from the carboxylic, the H from the carboxylic acid and the OH from the alcohol will combine and form water, and you can see the others will combine and form the ester. So one is the methyl butanate and the other one is aspirin. They have special importance, and we call as a O8, like in the naming esters are called as O8. Now here you can see it's a propanic acid, right? So it's a carboxylic acid. Okay, so now we are adding an alcohol for the other end, right? So what we call that here is acid is given as the biggest ester name, right? So we call that as propanoate. That is this, the propanoate. So the acid gives the acid number carbon is given for the basic name for the ester, and whatever the alcohol comes, what name where the alcohol is coming, we give the name in the front. So here the alcohol is coming as a methyl group, so we call methyl propanoate. Here you can see now this is the acid group CO. This the big group is the acid group. So you have seen 5 carbons, so it's a pent. So we can see it's a pentonic acid. So in this OH part, group is going to come and attach. So we don't know which group is going to come. So here you can see 2 carbons are coming. If it's 2 carbons, we know it's ethyl. So we put ethyl pentonate. It becomes an ester now. Now it's an ester because it's a reaction between acid and alcohol. A combine, and then the ester is formed, which gives a COO group. Okay, now in the esters, the most important reaction we have to see the condensation reaction. That means the condensation reaction is any organic reaction driven by the removal of small molecules like water. Esters are made by the condensation reaction between carboxylic acid and alcohol, and this reaction is acid catalyzed. So you need acid to make the ester, like carboxylic acid reaction with alcohol. I mean, we are releasing a water molecule. For that you need acid. Okay, we call that condensation reaction. Here you can see this OH and H combine and release as water, and then you can see the COO is forms. Now here you can see the 2 carboxylic acids are combined. So we call that acid anhydrides. Okay. A condensation reaction in any organic reaction driven by removal of small molecule is called condensation. So you can make not only esters, we can make acid anhydrides are made by the condensation reaction between 2 carboxylic acid. But for this one you don't need acid, you can just heat will help you. Now we are going to talk about ethers. So ethers mean you only have O group, and the side people are carbon groups, so alkyl groups. So they are so non-reactive groups because only O is there. So we call that, like if you have 2 groups in the other side of the O, so how do you name that? We call the 2 groups, that's all. Now here you can see in this molecule you have 2 ethyl groups in the both sides, so we call as diethyl ether. It is used as anesthetic compound. So now we talk about the amines. So amines are compounds which has nitrogen. So you can have nitrogen with a hydrogen, and any alkyl groups are connected. So they have very bad smelling, and they are formed when it has in our proteins nucleic acids. So when they decompose, you see all these amines are comes out. So they mostly, we also talked about amines in where? In our organic bases, like we call in weak bases, right? So we name alkyl groups attached to nitrogen. So if you have amine, you can see NH2 is there, but you can see in one end you have ethyl groups there. So we call that ethylamine. Now here you can see the other molecule, you can see N and H, but for the other position of the nitrogen, you can see a methyl and ethyl group. So we call that ethyl methylamine. So amines are very they are biologically active. Like have you heard about dopamine, a neurotransmitter? It has amine group. And if you have epinephrine, an adrenal hormone, pyridoxine, a vitamin B6, and alkaloids are plant products that are alkaline and biologically active. They are toxic: quinine from hemlock, and then cocaine from cocoa leaves, nicotine, and mescaline, and morphine. So these are all alkaloids. So amines are very important in most of our biological and other stuffs. Amines, we already talked about amines. They are weak bases. So they have lone pairs that can be donated to a H plus, so they act as a base. So here in this first reaction, you can see the RNH2, which has a nitrogen with 2 hydrogen with the R group, which R group means an alkyl group, any carbon group. So when it reacts with HCl, it extract the H plus and form RNH3 plus and Cl minus. So HCl donates H plus and the proton is accepted by NH2 and it acts as a weak base. We already learned about these reactions. Next reaction is the second reaction is between a carboxylic acid and amine. So carboxylic acid react as, and here it donates an OH minus, and the amine will donate an H, and it forms a condensation reaction, and it releases water and forms amides. So these are the types of major reactions of amines.